Good morning, good afternoon, good evening. It's your boy Mr. Malachi and welcome to this new video on simultaneous equations. So what are simultaneous equations? These are two equations. You're gonna obviously get two equations, right? And the whole point of solving these two equations is to solve them at the same time. So that's what simultaneous means. It just means at the same time. So rather, let me write same time, right? So remember again, we have two equations with two different unknowns. So we should be coming up with two solutions, right? One for each unknown. So where x is equal to something and where y is equal to something. So these are what we call simultaneous equations. There are different ways of solving these. I think there's probably like 3 or 4 different ways of solving these. I'm only going to introduce to you only 2 ways of solving these. So what do I mean by that? There are 2 ways of solving this. There's one using the substitution method, and there's another method which is called the elimination method. And as the word suggests, this one is when you are using substitution to solve it. So you're using substitution to solve these equations. And this one is when you are eliminating a variable, and so you are left with the other variable and you can solve that variable. So these are the 2 methods. Again, they're just 2 different methods of solving the same types of equations. And so yeah, you do need to know how to do both, and you just ultimately choose which one is better for you and which one will be easier for you. So let's start with the substitution. Let's take an example. All right, so we're going to use the substitution method, and we're given those 2 equations there, and we're going to first label equation 1 1, and we're going to label equation 2 2. And what we're going to do is we're going to take either one of those equations, take the one that's easier. I noticed that in equation 1 is quite easier to work with, so I'm going to take that equation 1 and I'm going to make equation 3 from it by either making x the subject or making y the subject. So what does that mean? If I make x the subject, I need to take the y over, and so it's 8 minus y, and this I call equation 3. Then once I have equation 3, I go and sub 3 into 2. So that's what I'm going to do. And so my 3 looks like that. I'm going to first write down what the 3 looks like. Oh, sorry, the 2 looks like that. Equation 2. And wherever I'm substituting, I'm going to show that in red. So in place of x, wherever I see x, I'm going to replace it with this equation of what x is equal to. So there we go there. I still have my plus 2y, and this is all equal to 21. Then I need to expand those brackets, and what you will notice is that only one variable is present now. So 3 times that gives me 24. 3 times y gives me a minus 3y, plus 2y is equal to 21. And this and that gives me a minus y. 21 minus 24. Negative y is a negative 3, and so y is a positive 3. So there is one of the values that I'm looking for, which y is equal to a positive 3. Then now that I've solved for the y, the quickest and easiest way to solve for x is to use equation 3. So here where I have equation 3, I'm going to take it again, and wherever I see y, I'm going to replace the y with the value that I just got now, which is 3. So you subtract with 3, and x is actually equal to 5. And those are the 2 values we were looking for. And there we go. this is how you do substitution. So again, let me take you through it. What do you do first? You take one of these equations. In my case, I took equation 1 because it was easier, and you make equation 3. And the way you make equation 3 is you either make the x the subject or the y the subject. What I did is I made the x the subject of the formula. Then I take equation 2, there's it down there, and wherever I see x, I replace it with what x is equal to in that equation 3. And once I do that, that x variable should disappear, obviously, because I replaced it with the y expression. And once I solve that, I should get one value for y. Then now that I've gotten that value of y, I take it back into equation 3 because it's much easier to work with, and I solve for the value of x, and there we go. That is basically how you do it. Let's apply it again onto another question. All right, so in question 2, we're given these two equations here, and we're asked to solve for x and y simultaneously. So the first thing I do is to label the equation 1 and equation 2. I'm going to take equation 1 again, and I'm going to make y the subject this time. So I'm going to take the 3x over, and if it gets to the other side, it becomes a minus 3x. Divide by 2 and divide this whole guy by 2, and so y is equal to 60 minus 3x over 2, and I call this equation 3. Then now that I have equation 3, what do I do with equation 3? I sub 3 into 2, always the one that you didn't use. So I didn't use equation 2, I used 1 to get 3, so I have to substitute into equation 2. So I'm going to rewrite that equation the way it looks from there at the top, and wherever I see y, I'm going to replace it with that fraction there, and that fraction is a 60 minus 3x over 2, and all of this is equal to 45. Then now that I have that equation, we've talked about how do we solve fraction equations. Remember, it is to find your LCD first, and in this case there's only one denominator, so that 2 will be my LCD. And then what I do with that LCD is I multiply it with everything. So the first term times LCD, the fraction times LCD, and 45 times LCD. Then what you will find is that 3x times 2 is 6x. These 2's cancel, but this 3 needs to multiply that binomial there. So negative 3 times a 60 would give me a negative 180. Negative 3 times a negative 3x is a positive 9x. So be careful, that guy is a binomial, so you have to times it with both those guys in the numerator. And a 45 times 2 is just a 90. My fraction is gone, like terms. 6 and the 9 will give me a 15x. A 90 plus 180, this is that degrees, sorry. It's 15x is equal to, that is 270. And I'm dividing by 15 there. I'm dividing by 15 there. And so x is equal to, just quickly check that into your calculator. 270 divided by 15 is just 18. So x is actually equal to 18. But am I done? No, you're not done. You have to take that x and you have to substitute it into equation 3 to find the y. So let's write equation 3 again. There's equation 3. And wherever I see x, I'm going to substitute it with 18. So 18 minus 3, In brackets, I have 18 for x. This whole thing is being divided by 2. You could just plug that guy in as you see it on your calculator. You don't have to do that arithmetic yourself. So get that. 16 minus 54 divided by 2 is 3. So y is equal to 3. And there we go. There's your y value and there's your x value. So again, just to recap, this is the substitution method. Basically what you're doing is you're taking one equation, you're making equation 3 from that equation by making either x or y the subject of the formula. You're then taking that equation 3 and substituting into the other equation that you did not use. In this case, it was equation 2. I substitute, I always have to use brackets there. And in this case, we had a fraction, of which was not a problem because we know how to solve fraction equations. It is just to find your LCD and times across with that LCD. And then we end up with just x at the bottom. And once we found our x, we always take that variable that you found, you always substitute it into equation 3, and that's going to help you to solve for the other variable. And there we go. Basically, this is what substitution is. Let's look at elimination and how that one works. So the elimination process needs us to eliminate one of those variables. So what do I mean by eliminate? If you have a look at this equation, we have equation 1, you can label them again, and equation 2. And what I notice is that the coefficient of x there is 1, but the bottom one is 2. So if I add and subtract those two equations, the x will not disappear, or rather it won't cancel. But I notice that the y is a negative 3 and the y down there is a positive 3. So what I need to establish in my head is a negative 3 plus a positive 3 would give me a 0. Right? And so that tells me that I need to be adding these two equations. And once I add them, the y would cancel out. It will give me a 0. And so that would eliminate itself. And once it's eliminated, I could just solve for x. So what I'm going to do is I'm going to just rewrite them here nicely underneath each other. So there's equation 1 and the x underneath the x, the y underneath the y, and the constant underneath the constant. And what am I doing to these two equations? I'm adding. So a 1 plus a 2 would give me a 3x. Negative 3 plus a positive 3 would give me a 0. We've already established that. Negative 5 plus that would give me a negative 6. So now my y is gone. I could just easily solve this equation. It looks like this. 3x is equal to a negative 6. Divide by 3, divide by 3, and so x is a negative 2. So now that I've solved for x, I can substitute in either one of those equations to solve for y. So I'm going to choose to use equation 2. So I have 2x plus 3y is equal to negative 1. I substitute for x, which is negative 2. And I have to solve for y. So 3y is equal, that will give me a negative 4, but when it goes to the other side, it's a plus 4. So 3y is equal to a 3. Divide by 3, divide by 3, and so y is equal to a 1. So this is how the elimination method works. You're either adding or subtracting the two equations to get rid of one of the variables. And yeah, once you solve for the other variable, you just take it and substitute it back into equation 2 or 1, whichever one you prefer, and you can solve for the other variable. In this case, it does not matter where you substitute, but in the first substitution methods, it does matter where you substitute. Always has to be the other equation that you did not use. All right, let's look at one more example on this elimination method. All right, so we have these two equations. The top says 2y minus x is equal to a 3. The bottom says 4x plus a 3y is equal to a 10. So what I'm noticing here is that these coefficients are not the same. For y, it's a 2 and a 3. For x, it's a -1 and a +4. So they're not the same. So instead, there's something that I need to do further from just lining them up and adding and subtracting. The further thing I need to do is that I could notice that for equation 1, if I times that equation by 4, then the coefficient of x will therefore be a 4. And now that it becomes a 4, I could just easily add and subtract those. So let's write it immediately after the multiplication. So it will be an 8y minus a 4x is equal to a 12. That's how it looks immediately after I just times by 4. You have to times every single thing by 4. So the guy at the bottom looks exactly the same, but what I could do is I could just move the y just so it comes first, because here I have a 3y coming first. So I put a 3y there, and I put my 4x there, and I put my constant underneath the constant. And now, do I add or subtract these equations? -4 plus a +4 would give me a 0. So that's how you decide. Just check on your calculator which one would give you a 0. So the addition one is the one that gives me a 0. So I add those equations. Sometimes you have to subtract them, but in this case I'm adding. 8 plus that gives me 11y. 4 minus 4 plus a +4 would give me a 0, obviously. And then this plus that would give me a 22. And this just looks like that. 11y with the 22. Divide by 11, divide by 11. And so y is equal to a 2. So now that I've solved for my y, I could just use equation 1, the original equation 1, and solve for my x from there. So this is how it looks. And then I'm substituting 2 there. I need to solve for x. So -x is equal to a +4 going to the other side, giving me a -4. This is a -1, and so x is a +1. If you divide by negative on both sides, you would get finally that your x is a +1. And there we go. These are the two values that I'm looking for. So yeah, sometimes you do need to multiply one of those equations, but sometimes you have to multiply both of those equations. So let's look at an example that looks like that actually. Alright, so this is quite an interesting question, because if you have a look at the coefficient of x, there's a 5 there, there's a 3 there. So clearly timesing one of them will not help, but instead what we could do is in equation 1 we could times that one with the 3, and in equation 2 we could times that one with the 5, and therefore we would end up with something, or rather two equations that now have the same coefficient of x. And also in y, you will notice that these are also not the same, and in that case we would have to times the top by 2 and times the bottom by 3 to end up with the same value that I'm talking about there. So you could choose whichever one you want to do, but I'm going to choose to rather change the x. So I'm using these factors here, timesing the top by 3 and timesing the bottom by 5. So if I times the top by 3, I'll end up with the 15x minus a 9y is equal to, let's just check, 24 times 3. 24 times 3 is 72. So this side I have 72. And the bottom, if I times by 5, I'll end up with a 15x plus a 10y is equal to a 15. And to get rid of these ones, to get rid of the x value, I have to subtract in this case. So 15 minus 15 gives me a 0. 9, negative 9 minus a 10 is a negative 19y. And a 72 minus a 15 is a 57. And once it looks like this, I divide by 19 on both sides, negative 19 on both sides, to get that y is equal to 3, negative 3. And so I have that y value. I could just substitute in either equation. This time I'm going to choose equation 1. So 5x minus 3y is equal to 24. I'm substituting the y. So it's a negative 3, open bracket, negative 3 equal to a 24. And you just do some algebra there. 5x with the positive 9 is 24. Take the 9 to the other side. You get 24 minus 9, and that is 15. And divide by 5, divide by 5. So x is equal to a positive 3. So there we go. This is my y value and this is my x value. And I hope you actually saw why do I need to multiply the top by 3 and why do I need to multiply the bottom by 3. That whole concept here of getting 15 there and 15 there is called the lowest common multiple. Or when you see it in fraction, it's called the lowest common denominator. So that 15 is actually the lowest common multiple. And so, yeah, that's how you go about solving these. I hope it makes sense. And I'll see you in the next video. Bye.